Hi everyone, today we will discuss about velocity and acceleration analysis of slider crank mechanism, that is by complex algebra method or analytical method. In my previous video I explained what are the formula required, what are the steps involved in this. So today we will solve one problem on this. So first I'll read out the question. Say in a reciprocating engine, length of crank is 250 mm, length of connecting rod is 1000 mm, and the crank rotates at uniform speed of 300 rpm clockwise. The crank is at 30 degree from inner dead center in IDC. So determine velocity of piston and angular velocity of connecting rod, and also find out acceleration of piston and angular acceleration of connecting rod by complex algebra method. So this is the question here. For slider crank mechanism, you have to find out velocity and acceleration of piston and also angular velocity and angular acceleration of connecting rod by complex algebra method. So first write what are the given data. So first of all, here a mean 250 mm, so that is given, that is length of this mean length of crank A equal to 250 mm. Next, length of B, that is length of connecting rod equal to 1000 mm or 1 meter. Next, 300 mean the crank rotates at 300 rpm clockwise. So this crank rotates clockwise direction at 300 rpm. So n2 equal to 300 rpm, that is minus 300 rpm, because for clockwise direction it is minus. So minus 300 rpm in negative x direction. So next, crank is at 30 degree from IDC, so theta 2 equal to 30 degree mean angle of this crank. So in this question you have to find out angular velocity and angular acceleration of connecting rod and also piston. So first one, angular velocity of crank. So you have to find out what is angular velocity of crank, this omega 2. So omega 2 equal to 2 phi n2 by 60. So 2 phi n2 mean minus 300 by 60. So you will get omega t equal to minus 31.416 radian per second. So that is angular velocity of this crank. Next, angular acceleration of crank, it is 0, alpha 2 equal to 0, because the crank rotates at constant speed. So you can directly write alpha 2 equal to 0, mean angular acceleration is 0 and angular velocity is minus 31.416 radian per second. So this is the first step. Now you have to find out what is this theta 3, mean the connecting rod angle, angular velocity of connecting rod and angular acceleration of connecting rod. So next, so first we'll find out connecting rod angle, mean this theta 3, this angle. So here to here, so theta 3 equal to, the formula is the sine inverse of minus of a sine theta 2 divided by b. So a mean crank length, b mean connecting rod length, and theta 2 this angle. So sine inverse of minus 0.25 into sine 30 divided by 1. So theta 3 equal to 352.82 degree. So in this diagram, this angle theta 3 equal to 352.82 degree. So now angular velocity of connecting rod. So angular velocity of B, that is omega 3 equal to minus a omega 2 into cos theta 2 divided by b cos theta 3. So first right? What are the given data? So A mean 0.25, then omega 2 minus 31.416, cos 30 divided by B equal to 1 meter into cos theta 3, that is 352.82. So you will get omega 3 mean angular velocity of connecting rod, omega 3 equal to 6.856 radian per second. Then find out angular acceleration of connecting rod. So after finding angular velocity, find out angular acceleration by using this formula, that is a omega 2 square into sin theta 2 minus a cos theta 2 into alpha 2 plus b omega 3 square into sin theta 3 whole divided by b cos theta 3. So apply the values what are given, then you'll get alpha 3 mean angular acceleration of connecting rod equal to 118.424 radian per second square. So this is angular acceleration of connecting rod. Now after finding out angular velocity and angular acceleration of connecting rod, find out velocity and acceleration of piston. So now velocity of piston, Vp in velocity of piston equal to a omega 2 into sine of theta 3 minus theta 2 whole divided by cos theta 3. So apply the value. So you will get velocity of piston equal to this much, mean 4.784 meter per second. This is velocity of piston. Next, acceleration of piston. Last step, acceleration of piston AP equal to a alpha 2 sin theta 3 minus theta 2 minus a omega 2 square into cos of theta 3 minus theta 2 minus b omega 3 square whole divided by cos theta 3. So answer will be minus 245.52 meter per second square. So acceleration of piston equal to minus 245.52 meter per second. So this is the procedure to solve velocity and acceleration analysis of slider crank mechanism by using complex algebra method. In my previous video I explained the derivation part, so that is the formula part. So just go through that. Thank you.